Hello everyone and welcome back to my YouTube channel. So in this tutorial, I'm going to show you how can you clone the Google Lens using Python. So for that, we actually using the TensorFlow, TensorFlow Hub, OpenCV and PyQt5. So now let's see how the application actually work. So for that, we need to click here to select the images and we need to select on images. If I click here to select these images and click here to open, and you can see here the predicted output is India gate. And this is the picture of the Indian gate. So this is also called a landmark recognition. So if I click here to select another images, so let's select the another images of the Ahsan Manzil in Dhaka, Bangladesh. And you can see here Ahsan Manzil Museum. So let's select another images. So let's select the images of the Adiyogi, my favorite, 1 and 2 feet Adiyogi. And also let's select another pictures of the Kedarnath temple. So you can see here Kedarnath temple. So in this tutorial, we are going to actually build this application from the scratch. So my personal request is please watch the tutorial till end because you are going to learn more amount of things inside the tutorial. So without any further ado, so let's get started. Well, in order to design the user interface, you're going to use the Qt designer. This is super easy to use and build one user interface. You don't need to write much more amount of code, just you can drag and drop and you can actually convert this UI into the Python code. So you need to just install this application for the Windows. If you are using Mac, you can actually download for the Mac. So just click on here and download it for the Windows. Okay, I'll put this link on the description. You can go and download this application. So now let's check this out. How can you actually use this in this Qt designer to design one simple UI, and after that, how can you convert this UI into one Python code? After installing the Qt designer and after opening that, you can see this kind of interfaces. So now I'm going to click here to file and create new main window here. Just click here to create. So this is our main window. That's been our application window. You can also say the user interface window. And in the side, you can see here input widget, that all are the widget in PyQt5, that's been Qt5. And also the display widget. This is for displaying the widget. And you can see here buttons and spacer and also the layout. Okay. And also you can see here the container also. You can also use that. So how can you use that? It's super easy to actually use that. Just drag and drop here. And you can actually using this to actually build this kind of application. So now you're going to actually cloning the Google Lens. So that's why it looks like one kind of mobile phone. So you're going to actually resize that. So let's resize it out like one mobile phone. Cool. So we're going to remove this status bar, not a status bar, it's called the menu bar. And also we need to actually remove this status bar from here. Now we're going to take one graphics view. Okay, so just drag and drop here and just resize it based on your screen. You can also go on the from and also see the preview of that. You can see this is the preview of the application, right? So your application looks like that. So now you're going to take one label here and also one images and one simple button, right? So you can also use here HTML and the CSS to design the button and also the text. That's mean you can actually design this. Just take one label here, drag and drop label. So we are going to actually edit that. So let's say Google Lens. Well, so now you can actually drag and drop. We can resize them, and also you can see here the toolbar. You can see here the Q object, and the object name is nothing but label. And also you can see here some property of this labels. So you're going to actually resize this. That's when you can give here some font size here. You can see if I give here font size as the 18, just use this, and you can see your font size is right now increases. Google Lens. Cool. Just drag and drop. So now we're going to take one picture here, right? So to take the picture, you're going to actually take one another label here. Okay, just remove this text label and just click here and right click, and you can see here change style sheet. Just click on here the change style sheet and click on the add resources and just click on this pen button, not pen, it's called pencil, and click here to create one QRC file. Inside this folder, you need to actually save this resource file. So let's say Google, save it. So now you can see here one QRC file is actually saved here. Now you need to select one picture, click here to create one new prefix, and after that you need to select one picture from here. So you can see here one picture is already there, unnamed on my folder. Just select this and click it to open, and just select this one, open, and just OK. And you can see here you got some error. It's a invalid style sheet. So this style sheet is nothing but the CSS. Okay, so for that you need to actually use here one tag that's called image. So now if I click it to OK, and you can see here our image is appeared here. Cool. You can see our image is appeared. Okay, well, you can also make it so bigger. So now we need to take one button, right? So let's take one button here. So where is this push button? Yep, this one, push button. Well, so now we can also change this text. So let's change this text to the select image. Okay, so now I'm going to give here some CSS style sheet. So just click on here, right click, and change to the style sheet. And you can see here this is one push button, and the class name is nothing but called the Q push button, right? So you can actually use this Q push button to actually design our button, right? That's our class. Okay, now we are actually using this class to actually design our button. So this is nothing but also as the CSS, you can actually use the CSS property here. So let's say push button. So in the CSS, make sure that you need to actually use one dot property. So let's say dot Q push button. You can, if I give here one color, so let's say color, let's say give here red color. If I click it to OK, and you can see here our text is converted into red color. So now I'm going to actually again open the style sheet, and I'm going to paste here some code to design this button. Okay, so let's paste it out here. So this is the Q push button, that's mean these classes, and I'm going to put here one background color and also the border radius. That's mean it looks like one rectangle, not rectangle, actually you give here some border radius so that it looks cool. And also one color is a black, and the border we give here border is 2 pixels in the solid and the color. And also we actually using one hover effect to look, it's very cool. So that, and when actually hover this, our background color should be converted into white color, and also our text color should be converted into black color. Just click it to OK, and you can see here cool button is appeared. So we can also change this text size. So just click on here, and you can change this text size. Let's say use this one, select image. Cool. So now our UI is completed ready here. Okay, so now we need to save it, right? So in order to save this, what we are going to actually do here, we are going to just click here to file and click here save as. So we're going to save as inside our Google Lens clone folder. So let's give here one name. So let's say Google UI. Save it. So our UI is right now saved inside our Google Lens clone folder. So now we're going to convert this UI into one Python code. So for that, we are going to actually using one library in Python that's called the PyQt5. So well, you can see here our UI file inside our Google Lens clone folder, and also the QRC file, and also the picture. Okay, so in order to actually convert the UI file into the Python file, you need to also installing one library that's called the PyQt5. So for that, you need to open your command prompt here and type here pip install, and the library name is called the PyQt5. Okay, you need to just install this library to actually run this Python file on your system. So I'm not actually going to install this because it's already available in my system. So I'm going to click it to close that. So now I'm going to click here on this box and type here cmd. So now we need to convert this UI file into the Python file. So for that, you're going to use one command to actually convert this UI file into the Python executable file. So for that, piuic5, this is the command for that, piuic5, then x, then o, that's been the output, and your output name should be the Python file name. So let's give here main.ui and your UI name. So our UI name is Google UI.ui. That's our file name. So you can see here one Python file is automatically generated. Cool. So now I'm going to click it to close that here. So now I'm going to right click on here and open with code. Well, and you can see here a Python file is created, main.py, and you can see here some code is automatically generated. Well, so now we need to actually run this code here. So I need to actually just remove this import Google QRC because we do need right now the QRC file. And also we need to change this new prefix file. Just you need to actually remove this. Just save it now. We can also remove this comment out. No, we don't need that. So now if I save it and if I trying to actually run the code here, and it will take a few seconds to actually run the code, and you can see one GUI is appeared, and you can see our main window, and you can see Google Lens and your images and also the select images. You see the exact same you design in the Qt designer look like that. So now you can actually change this icon and also the name of the application. Now I have to click it to close that. So well, so you need to actually change this the app name. Let's call the apps. And now you can actually also the change the icon of the application. So for that you need to also import here one thing. So from the PyQt5, we need to actually import the Qt icon. So it will actually available on the Qt GUI. We are going to import here the Q icon. Let's say Q icon, this icon. We're going to use this Q icon to actually set the icon of our applications. So for that, we're going to set this icon inside our menu. So let's say call the main window dot set window, the window title, and another one is called the window icon. So window icon, and inside that you're going to actually use this Q icon, and just you need to actually give here the path of your icon. So let's give here the path of your icon. So this icon name is the unnamed. Okay, so unnamed .png. Well, just save it and run the code here again and see that icon is changes or not. Well, and you can see here our icon is also changes and our application name. Google Lens, you're the picture and also the button. So now we need to make it functional. So when you click this button and we need to actually select one picture, and after selecting the picture, we're going to predict that what the image actually, what is the actual image for that. That's been the landmark recognition of the image. This is the picture of the Adi Yogi, this is the picture of the Pashupatinath temple, or this is the picture of the Taj Mahal, like that. So for that, you're actually using the TensorFlow Hub landmark recognition model that is already available on the Google. And this is taken care by the Google. So you're going to be using this pre-trained model to actually classify the images that is landmark of the images is from the Adi Yogi or the Kedarnath or the Pashupatinath temple. So let's jump on here. Well, we already built the Google Lens UI, and now we need to actually make it functional so that it can classify the images. So for classify the images, we actually using the TensorFlow Hub, and inside this TensorFlow Hub, there is some pre-trained model that is already available. And this is the official website of the TensorFlow Hub. So it is using the landmark recognition process to actually classify the images. So I'm going to click at all collections here. We are focusing on the landmark recognitions. So for that, I am going to searching for the landmarks. And you can see here the landmarks in the collections. Just click here on the landmarks. Okay, so it is available in some continent, Africa, Asia, Europe, North America, South America, and Oceania, the Antarctica. Okay, so I am from Bangladesh, so this is the continent of the Asia. So I am going to focusing on this Asia one. So I'm going to click at the landmark classifier for the Asia. And you can see here one simple application here. This is published by Google. You can also test it out here, your landmark classifier. For that, you need to actually click here to upload one images. So let's use this one. This is the image of the Adi Yogi. And you can see here 1 and 2 feet the Adi Yogi. So you're actually using this model to actually classify, or you can say predict the images, how it is from. Okay. So you can see here some model format. It is available in the TF, that's mean TensorFlow model, and also the TF Lite model format. If you are trying to actually use it in the ML kit, and also you can also import it into the Android S3 if you're working on the Java, and you can use this TF Lite Tux library also. And if you're actually using a Raspberry Pi, you can also use this TF Lite one here. So it's actually takes some inputs, as here you can see take the input as the RGB color images, you need to actually give here the RGB color images, how you actually give the input inside your model. And also your image size should be 3 to 1 cross 3 to 1, and image should be scaled between the 0 and 1. That's mean you need to divide the images by 255. Okay. And also you can see this model output is the prediction, the colon, the logits. So this is the most important part. So when you actually give the input, you make sure that your image should be in a RGB color, and it should be resized in the 3 to cross 3 to cross. Okay. And also you need to scale them, right? So now I'm going to actually copy this URL, and I'm going to test it out inside our own machines. So now I'm going to open my Jupyter notebook. So for that, let's say CMD, and let's type here Jupyter notebook. So first you're going to test it out that is working fine here or not. Then we are going to actually implement it inside our applications, right? That's been our PyQt5 applications. Okay. So let's make it full screen. Now let's click here to create new Python file here. Let's say Python 3. So now what I'm gonna do, let's say actually rename this. Let's say model test. Okay. Now we are going to actually import here some library here. So now let's import here pandas first. Let's say pandas as PD, and also we need the numpy as the np. Let's say import numpy as np, and also you need to import here the tensorflow as tf, and also you need to import here the TensorFlow hub. So make sure that you actually installing all the library on a system, and it's already installed in my system. So that's why I don't need to actually install the TensorFlow and the TensorFlow hub. So let's say as hub. Okay. So now we need to actually using the link to actually get the model and also the label. So I missed here one thing. So how the labels actually look like. One more thing, that is you can see one link that is for the label map, and you need to actually give here the one label map as one kind of dictionary. That's been your ID and your the value. That's been keep here value like that. You need to give here the label as like that. Okay. So now I'm going to paste here the link of the TF model URL and also the label map URL and our image shape. So this is our TF model URL that is already copied here, and also the label map URL and the image shape, right? So this label map URL is nothing but one CSV file. So if I'm trying to actually using read this CSV file inside our Python file, so for that we're actually using the pandas library. So let's say this our df, that's in our data frame, equal to pd.read CSV. Okay. So to read the CSV, we're actually using this here read CSV method and our path. So this is our path label map URL. Well, so if I see this df, this is one ID and this our name. That's been our label. Well, so now we need to also build our classifier to actually load this TF model URL from the TF model URL, right? So for that, what I'm going to do, you're going to actually create one variable that's called classifier. And inside this, you're actually using this TF. Let's say TF.characters. You're actually taking one sequential model. So let's say sequential. Inside the sequential, we need to pass here our model. That's been our TF model URL, and it is shape and also the output. Okay. So for that, you need to actually using here the hub. That's been our TensorFlow hub because it's from the TensorFlow hub. So let's say TensorFlow hub. That's been half dot. We need to actually using this keras one. So let's been our keras layer. So let's say keras layer. Let's say keras layer, and inside that we need to actually give here our what is called. We need to give here our TF model URL. That's our TF model URL. Let's copy this out. TF model URL and our the input shape. Okay, so our input shape. So it just looks like that input shape. So our input shape should be the 321 cross 321 cross 3. So 3 is nothing but our channel. So for that, you need to give here our input shape should be the our actual image shape and plus 3. Okay, so our image shape and also the plus 3. That's been our 3 channel. So 3 channel like that. And now we need to give here also the output key. So our output key is nothing but about the predictions logit. Okay, so output, let's say key equal our the predictions logits like that. Well, so now we need to actually run this. It will take few seconds to actually load that, and you can see our TensorFlow. This one TensorFlow actually loading here the graph. So now if I try to see the classifier, let's actually give it the classifier, and you can see here this is nothing but one sequential layer. Okay, well, so now what we need to do, we need to actually now we need to actually creating this label. We need to actually creating, you can also see the summary of the classifier. So this our model, it is actually have the keras layer having this kind of input. That's been our, this our nothing but our output. Okay, that's been, there's so many levels like that. So now what I'm going to do, you're going to actually creating one level map for that, so that our input and output, our output of the classifier and our the level map should be the same. Okay, so for that we need to create one level map here. So let's say level map. So let's say level map. Let's take one variable, let's call level map. And now we're going to create one dictionary for that. And we're going to, because we need to create one dictionary and it have the key pair below. So we're going to zip this based on our df.id and also our df.name. Because we have the, if I see this df, just actually click here and see the df dot, let's say head, let's say take the pipe one. So you can see here one id, we need to actually make it as a dictionary format. So that's why you're actually using the dict keyword, and also you're going to zip that in the based on the id and the name. So it will actually make one level map. So if I trying to see the level map here now, so our level map look like that. You have the one dictionary, 0 and 1 2 like that. Okay, well, so if I trying to see the shape, I think you don't have any shape maybe. Okay, because it is a dictionary, right? Okay, so now what I'm gonna do, we actually initialize the classifier and also our level map. So now we need to actually predict the images. We can actually load the images, and after loading the images we can actually test it out. So well, so we actually make our level map and also the classifier. So now it's all are set. So now it's time to test it out that our model actually working here fine or not. So now we need to actually load one images. So for that we actually using our the CB tool, that's been our OpenCV library. So make sure that when you read the images, you need to convert this image into the RGB, because OpenCV read the image in a BGR format. So let's actually import here one image. Let's say image equal to cb2 dot, let's say I am read. So I have one images inside my directory that's called the puri.jpg. Puri.jpg. This is the image for the Jagannath Puri. So we can also show it. Let's say cb2.imshow, and we are going to actually give here one simple frame here, and let's say our image, and also we need to give here one wet key. Let's say cb2.wet key, and we are going to give here 0. So it will actually load the images and take few seconds to load that. Well, image is actually loaded, and you can see the picture of the Puri. So we need to also resize the picture, right? And also we need to convert this image into the RGB, right? So this image is quite big. So let's also resize the images. So let's say resize equal, let's say cb2 dot resize, and let's give here the image, and also the, let's say 640 and the 480. Now let's save it, and also let's enter it here, and you can see here the image. Okay, right now it's quite big. We need to actually using this resize one, right? Okay, well, so now you can see the picture of the Puri, Sri Jagannath Puri temple. Okay, so now it looks good. So now we are going to convert this image into the RGB image, right? Right now it one visual image. So I'm going to click it to close that. So now you're going to convert this resize image into the RGB image. So for that we actually using here cb2 dot cbt color, and inside this we actually give here the resized image, and also we need to give here one color code. So let's say color bgr2 RGB. So now our image is converted into the RGB images. So let's give here the RGB image like that. Okay, so after actually convert this image into RGB, now we need to also resize the images based on our model. Okay, so let's say based on our model, let's actually copy this out, and also let's use it the same name, and now we need to convert it into 321 cross 321, right? Okay, then after resizing the images, you need to also scale the images. So for that we actually using numpy to actually resize the whole images. So let's say RGB image. So let's say RGB image equal to np.array of our images. Let's say RGB images and divided by 255. So now our image is also a scale. So because this is one CNN model, we need to also reshape them, right? So for that, actually using the reshape method, that's been one axis. So inside the reshape method, you need to actually give here our RGB image. That's been our this RGB image. And also you need to give here one resize, that's in 4-dimensional. So 321 cross 321 cross 3. So 3 is nothing but a channel. That means it's the 3-channel images. That's in RGB images. And after reshaping the images, we can now classify that. So let's say we actually using the predictions. Well, and now we're going to use the classifier dot predict and our image. So this our RGB image. So if I actually run the code here and classifier is not defined, okay, well, so maybe this is one classifier. This is not the classifier. So let's say classifier, this one. And I think we get some output here. Okay, so let's try to print the predictions here. So how the prediction actually looks like here. So let's say print the predictions. So this is one actually this one kind of array with actually containing some values. So now we're actually using the label map to actually get the value and also the argmax. Okay, so now we are going to use here np.argmax, okay, argmax function to actually take the maximum value of the predictions, and also we actually using the label map to actually get the actual level of the images. Well, so now let's say inside this label map we have the RGB and this is our result. Well, so result equal to label map. So now if I try to print the result here, so result, and you can see Jagannath temple in Puri. Well, cool. So now we need to actually implement this whole code inside our UI, that's in our PyQt5 applications, right? So we can also define here one simple method to make it more classified. So let's say classify image, and which one take one image, okay, as the output, as the input. That's when you're actually making one functions to make it more classified, right? So just you need to copy this out, just copy this out here, and just you need to paste it here, okay? And now we need to actually use this predictions, and we are going to finally return there. Return, which one we need to going to return here? This one, right? Okay, so now if I use this one, let's say we need to actually make it should be image. So now if I actually using this classify image function, or you can say method, and give here the path of the images, let's say puri.jpg. So you can see here we got the output of the Sri Jagannath temple in the Puri. Well, so now we're actually using this one to actually classify the images so in our applications. So let's go here. Well, so this is the code for the UI, that's been our graphical user interface. So now we're going to click it to run this code again. And you can see here our application is upping run, and you can see the image and also one button. So you need to make this button should be functional so that we can actually select the images from our directory. For selecting the images from our directory, we're actually using the GUI file dialog. So I'm going to click it to close that, and also trying to import it here. So let's say from the PyQt5, okay, this PyQt5, we are going to import it inside our the Qt widget. So let's say Qt widget. So this is the Qt widgets, and import here the GUI file dialog. Okay, this one. So actually using this GUI file dialog to access the file from our directory. So we need to make the push button, that's when our select image button should be functional. So if I go down, you can see here one functions, or you can see the method that's called the retranslate UI. So now you need to actually tap here, and let's call self your button name. That's been our push button. So let's say push button dot when I click it. That's been when I click this button, we need to also connect it. We need to connect it on one method. Let's say self dot one method name. So let's say upload image. So when you actually click this upload button, one function or you can say method should be called. So you need to also implement this method here. Let's say def upload image. Okay, well, so we need to also test it out that is working fine here or not. So for that you're trying to print here something. So when I click the button, it will actually printing this one. Let's say button clicked. Okay, so let's say clicked. Well, so let's save it now and also run the application here. And now you can see our application is opening. If I click here the select images, and you can see a button clicked. Well, so button click, button click. So right now our button is working here. So now when I select click this button, or one file dialog should be open and we can select the images from here. So for that, what I'm gonna do, we actually using this GUI file dialog, right? So let's actually initialize here one variable. So let's say file name. Okay, let's say file name. And now we're actually using this GUI file dialog here. So let's say GUI file dialog dot get. So get, we need to actually getting the file names here. So let's say get open file name. We're actually using this method to actually get the file name from here. So this is our path. So let's give here the path of that file name. So let's say file name and the index number 0. If I am trying to actually print this path here, we need to also convert it into the string so that we don't have get any error. So if I trying to print the path, so let's say print the path. Let's save it now. And if I am trying to run the code here again, and now if I select the images, and you can see here one file dialog is open, and you can see the image is inside our the Google Lens clone the folder. If I select the image of the Puri and open here, and you can see here D drive inside the deep learning project folder, you can see a Google Lens and the picture name. So we actually get the path of the images now. So now what we're gonna do, we are going to actually using these images, and after that we actually classify the images. So I already convert this Jupyter notebook inside one Python file. You can see your main model task.ipnb file into one model task.py file so that I can copy it easily. So you can see here, you need to copy here something here. I need to copy first the module that is needed to actually run the code. That's in our predictions. So we are going to actually use this here. And after that, we need our this here and this are also same. You can also copy this from here. I just convert it into Python file. If you don't have any Jupyter notebook, you can actually use this Python file. So that's why I actually convert it. Okay, just simple. And we need to also copy this one. Let's say we need to also copy this classifier. So let's actually copy this classifier also. So let's use this one. Okay, we can remove this out. We need also classifier. We actually read the images from the CSV, not CSV. We actually read the level from the CSV, and we need also this dictionary. That's in our level map, and also the functions that we actually built. Okay, so let's go down here and just copy this out. The function, yeah, this one. So we are going to do some customizations inside our functions. So we actually resize the images, find and select the images, and after that actually converting this into the scale them and also reshape them. Just you need the predictions. So you can actually just actually remove this line from here. Okay, and we can actually give here this RGB image like that. Okay, well, so now it actually gives here the level map and also the classification below. Now, so when I click this button, we need to also read the images, right? So let's say image equal to, you're going to use the cb2 here, that's been OpenCV to read the images. Let's say cb2.imread. We actually read the images based on the path. And after reading the images, we are going to actually convert this image into RGB images, and also we need to also resize them. So let's say we are actually resizing the images. So let's say one variable that's called bgr images so that we can actually show it later on. So let's say cb2.resize. And inside this, we actually pass the images and also the size. Let's say 640 and the 480. This is nothing but for the show the images because our image is very big. So that's why in order to show the images, we actually just resize it. Okay. So now we need to actually convert this image, actual image, into the RGB images. So let's say RGB image. equal to cb2 dot cbt color, and inside it we actually pass here our images. That's been our these images or these images. We actually resizing is just show it, right? Okay, so images, and inside that we are going to actually give here one code. Let's say cb2 dot color bgr to rgb. Okay, and after actually converting this image into bgr to rgb, we need to also resize the images based on our requirement. Okay, so let's say rgb image equal to cb2 dot resize, and inside that we actually give here our rgb images, these rgb images. Okay, and also we need to actually give here the size, so this should be 321 321. And also what I need to do, we need to actually just actually give this full image inside our classify image function, right? Or you can say method. So it actually give here one result here, like the result equal to our classify images. That's mean when actually call this classify image function. So this classify image function take the images as the RGB images, this one. And if I go this classify function images, it actually take the images and it will convert this image into a 0 to 1. That's means scale the images, and after that it also reshape them and give here the predictions and also as a label map. So this result is nothing but one string. Okay, so now we need to actually show the images also. Let's say cb2.im show, and after that we actually show it inside our OpenCV. Let's say frame, and we are going to actually use this bgr image here. So let's say bgr image. Okay, and also we need to give here one white key. So let's say cb2.white key, cb2.white key here. Okay, let's use here cb2.white key, and we need to actually give here 0 inside it. Okay, why it's not actually working? cb2.white key. Well, fine. Okay, so now if I actually save it and if I run the code here, we can also try to print the result. Okay, so let's say try to print here the result. Let's say try to print the result here also. Okay, we got some error here because we actually forget to actually import the cb2, right? So we need to also import it here. So let's say import cb2, and now our error is gone because my PC is getting very slow because recording is actually started and also the internet connection, so that's why. Well, so our error is gone. So now I am trying to run the code here. Just click on this button and run the application. So when you run the code for the first time, it will actually take few seconds because it will actually download the model from the internet. So based on your internet connection and also your machine configuration, it will take few seconds. Well, so you can see here our application is up and running down. And if I click here to select the images, and if I select the image for these 4 images and open here, and you can see here the path of the images and also the prediction, right? And you can see here image is also appeared on here, and also you can see the prediction. See Jagannath Puri, Jagannath temple in the Puri. So this is our output. So now we can also show the output in a text. That's mean put text and also one rectangle, right? Okay, so I'm going to paste here some code. I'm not going to type it here again and again. So let's say cb2 rectangle, the visual images and also one put text which have been predicted, and I have the string format and also the coordinate and also the font type and the scale and the color of the font. Okay, so just save it, and I'm going to click here to close this one. Okay, you don't need to save that here because it's already okay. And now I'm going to actually run the code here and also try to test it out. Just click here to run the code. Well, so now we are going to test it out here. Let's say select the images. Let's go on the download and select the picture, and this is the picture of the Pashupatinath temple in Nepal. Yep, predicted Pashupatinath temple, and this is in Nepal. And click here to close this here, and let's select another images, and this is the picture of the Taj Mahal. Yep, Taj Mahal. Well, select the another images. So let's image the picture of the Dakashari Mandir in Dhaka, Bangladesh, and you can see here Dakashari Mandir. Okay, and let's select another picture of that. So let's select the picture of the Kedarnath, my favorite Kedarnath temple. Okay, and click it to close that, and also select another images. So let's say our national, that's in our national parliamentary house, Jatiya Sanshad in Bangladesh, and also select here another images. So let's say the Hassan Manzil, and you can see our Hassan Manzil museum, it's on the Bangladesh. Let's select another picture of the Sri Jagannath Puri. Okay, and you can see our Sri Jagannath temple in Puri, like that. Let's go outside, and also let's select another picture of the Adiyogi. Yep, you can see here 1 and 2 feet Adiyogi. So this is all about the Google Lens clone using Python and the PyQt5. You can also test it out using some another continent of Africa or the North America. I'm just focusing on the Asia. So how I actually give here the images from the Africa, it's not unable to predict that. So you need to actually give here the landmark of the images, that's in landmark recognition images from the Asia. Okay. So now your job is to try it for different continents like Africa and North America. I'm just focusing on the Asia. So that is all about this whole tutorial. So you can actually using the Kiwi framework to actually building this kind of also user interfaces. And after that, you can convert this Python code inside your Android application. That's been Py to APK. You can also test it out from here. So this is all about the whole tutorial. Make sure that you subscribe to the channel and also support me, the knowledge doctor. So I'll be back with another tutorial. So till then, take care and bye bye.